This is R.D. Sharma solution, class 12, chapter 5, Algebra of Matrices. Exercise 5.5 we are taking. In this exercise, we are actually dealing with the symmetric matrix and skew symmetric matrix. So I'll just give you a hint, an idea with this question, what exactly we mean by symmetric matrix and skew symmetric matrix. So in this question, if the matrix is given, we have to prove that A minus A to the power T, this is a skew symmetric matrix. What does it mean? That if I write this matrix 2, 3, 4, 5. Now when we take the transpose means you have to change the rows to columns. This is first row. Now just convert it into the columns. That is, see, this is column. So what do we do? 2 here, 3 here. So row transported into or converted into column. 4 and 5, this will be a column. This is row, so there will be a column. Okay. So row has been changed to column. So this matrix is called as the transpose of matrix. If this is A, this is going to be transpose. So we put a T over A. When it is symmetric, if A is equal to A transpose, that is symmetric. But in case if A is equal to negative of A transpose, because if you transpose a matrix and it is actually equal to the negative of the actual matrix, then we call that this kind of matrix are skew symmetric matrix. So this is A transpose, and it is, the question is asking A minus A transpose. So let us take the difference of these two. That is A minus A transpose. So I am writing A and then A transpose. So 2 minus 2, I am just doing it here only. 2 minus 2 is 0. Then 3 minus 4 is negative 1. Then 4 minus 3, it's 1. 5 minus 5 is 0. This is what? This is A minus A transpose. Now A minus A transpose, let us take the transpose of this total value. So this is the final matrix, you can call it as X. So you are taking X transpose. So row to column, so 0 minus 1 will come here, 1 0, 1 0 will come here, 1 0. Okay. Now you see it very carefully. But if I take negative count from here, that is just multiply negative 1 with each and every element, scalar multiplication. So if I take minus common, everything else will inside will be changed. So 0 minus 1, 1 and 0. So this is what? A minus A transpose. But it is negative of it. That is, negative of A, if we call it as X matrix, the X transpose is the negative of X. So this is a skew symmetric matrix. This A is given, A minus A transpose is a skew symmetric matrix. This we have just seen. So same thing you have to do. So I'll just give you an idea here, overview actually. This is A transpose, row to column. So it will be transpose. Now A raised T. So just subtract these two, A minus A transpose, you will get this one. Then you take the transpose of this. 0 minus 5 will come here and minus 5 0 will come here. So the transpose is, and you just take the minus out of it. Means you can say just multiply negative 1 inside. So what you get is the matrix which is coming is the negative of the A minus AT. Let me tell you again. If you have a matrix A and if you take the transpose, if they are equal, then A is symmetric, but if it is negative, it is skew symmetric. If matrix A is symmetric matrix, find X, Y, Z and T. So as I said, the symmetric matrix is when you take the row to column, the matrix remains unchanged. That means the sign remains unchanged. It is similar to your A transpose. So you have phi 2x, y z negative 3, 4t minus 7. Let us take the transpose of this. Transpose is simply changing rows to column. This is A transpose. So what do you get? I am taking transpose here. This 5 to x will become the columns of 5, this 2, and this is x. Yz minus 3, same here. Column yz negative 3. 4t negative 7. This row has to be converted into column 4t negative 7. Okay, now equate. When you equate, what are the values? What is x? Let me show you with directions. X is equal to 4 here. Y is equal to 2 here. T is equal to negative 3 here. And z has no value. Actually, z is equal to z because there is no value of z we can find out from this particular scenario. So z can only be written as z, right? So A is a symmetric matrix and x, y, z with t value is like this. When we converted row to column, these are the values which found. If A is this, find matrix or matrices x and y such that x plus y equals A, where x is a symmetric and y is a skew symmetric. Now, how do we do this? The next question I will do it properly. Here I am going to give you an idea. How do we do it? Find matrix x and y. So you have to write x and y such that when you add them, it has to give you the answer as A. Okay. So this x, see, x is what? Half A plus A transpose. X is half A plus A transpose. What is y? A minus A transpose. Make it half. So x and y, when we add, what do you get? I am adding x and y now, which I took these values. Half I am taking outside. A plus A transpose plus A minus A transpose. Right? What do you see? A transpose is A transpose, you cancel. It is 2A. This is half of 2A. 2 gets cancelled. You get A. You got the idea? So that is why we took x and y as these values, because we need to add them and that has to be equal to capital A. That is matrix. So the x needs to be, I'm going to make the x here, and this x has to be a symmetric matrix. That is, when you take the transpose, the same matrix should come. So A transpose is what? Row to column. So 3 to 7 will be the first column. 1, 4, 3 will be the second column, and negative 2, 5, 8 will be the third column. Okay. So this we have taken the transpose. Now A and A transpose we will add them. A and A transpose we have to add. So A plus A transpose we are doing. A and A plus transpose. So first we'll add them, then we will divide it by 2. Just add these two. This is 3 plus 3. I'm adding here only 3 plus 3. A is this, A transpose is this. So 3 plus 3 is 6. 2 plus 1 is 3. 7 minus 2 is 5. 1 plus 2 is 3. 4 plus 4 is 8. 3 plus 5 is 8. And negative 2, 7 if you add we get 5. 5 and 3 when we add we get 8. 8 and 8 we get 16. So this is the A plus A transpose we got. But there is half also. As I said, we made x as half A plus A transpose. So this is just A plus A transpose. We have to take the half also. That is, multiply inside with 1 by 2. So divide by 2 essentially it means. So 6 by 2, that is 3. 3 by 2. 5 by 2, 3 by 2, 8 by 2 is 4, 8 by 2 is 4, 5 by 2, 8 by 2 is 4, 16 by 2 is going to be 8. Now, this whole is your x. And y, let me show you here only. See, now you have to subtract these two. So I'm subtracting now. These two A and A transpose which we found out. Now you have to subtract. This will come and you have to divide it by 2. Then this will come. So X and Y has come. But the thing is that X has to be symmetric and Y has to be skew symmetric. So you have to show that X transpose, that is you have to transpose the X, you have to transpose the Y and show it that the X transpose is coming X and Y transpose is coming negative Y. I hope you got the idea. I am saying X is symmetric. So you have to show that when we transpose X, the same matrix is what we are getting. And for Y, when we transpose, the negative of Y we are getting. Okay. So X, this is, now I'm just transposing it. This is what I'm regarding it as X. So this will be 3 by 2, 5 by 2, I'm transposing it. This will be row, so 3 by 2, 4, 4, 5 by 2, 4, 8. Okay. Now you see these two matrices are exactly equal. So this X transpose is equal to X. When you take Y transpose, it will be negative of Y. Okay. That is why it is skew symmetric. So you have to show that. So this you have to show, but the things are not even done now. We have one more step. The step is the actual is X plus Y, because how it started. We said when we are taking X, we are taking Y like this, when we add you get it as A. So you have to add the X and Y. Finally you have to add these two X and Y, that is these two matrices, and then final answer will come. That is going to be A. You have to show that it is coming as A. Express the matrix A, this one, as the sum of symmetric and skew symmetric matrix. Now, as I said that we'll do it properly, because this is the question which is supposed to come in the exam. This is a very important question. It normally comes in 5 marks. So we'll do it one by one. See, sum of symmetric and skew symmetric. So how do we do this? If this X can be written as half A plus A transpose, Y will be half A minus A transpose. So when we add X and Y, this A transpose will get cancelled. 2A divided by 2 is A. So X plus Y will be actually equal to the same matrix A, right? Now, in order to find X, you have to transpose A and then add it to A and divide by 2. So step by step we'll do. I'm taking A transpose now. 4 to negative 1 means this is the actual matrix, and then we have to do the transpose. So this is the actual matrix I'm writing, and with this only we're going to write the transpose. So the row will become column. This will be 4, 2 and minus 1, 3, 5, 7, 1 minus 2 and 1. Okay, so this is your A, this is your A transpose. We have to add them. Means corresponding members we have to add. 4 plus 4 is 8. 4 plus 4, 8. 2 plus 3 is 5. 1 minus 1 is 0. 3 and 2, 5. 5 and 5, 10. 7 and negative 2, 5. 1 and 1 minus 1, 0. Minus 2 and 7. 7 minus 2 is 5. And 1 and 1 is 2. It's not 0. I'll just change it. It will be 1 plus 1, 2. So now we have to divide it by half also. Then only we are going to get X. Because X is nothing but A plus A transpose divided by 2. So you have to multiply this by 1 by 2. So what do you get? 4. This is 5 by 2. Then you have this 0. This gets 5 by 2. This is 10 by 2, 5. 5 by 2. 0, 5 by 2 and 0. So this is your final X. This is your X value. But X has to be symmetric. We'll show that just now. But let us go for y first. So this is x. Finally, x is this one. This is your x. This is your final x. Now coming to y. I'll do it here only because we'll subtract it. Rather than writing it again, I'm just subtracting these two. Let us subtract. So this whole is for computing x, which we have already computed, x. This is we are computing y. Y has to be the subtraction of A and A transpose. So 4 minus 4 is 0. 2 minus 3 negative 1. Minus 1 is minus 2. Negative 2. 3 and 2 if you subtract you get 1. 5 and 5 subtract 0. 7 minus of minus 2 will be 9. 1 minus of minus 2 will be 2. Minus 2 minus 7 is going to be minus 9. And 1 minus 1 will be 0. Okay. Now, so what we have got, this is your A, this is your A minus A transpose we have computed up till now. So A minus A transpose is this one. But in order to find y, we have to divide it by 2 also, half. Now divide it by 2. It will be 0, 1 minus 1 by 2, minus 2 by 2 is negative 1. This is 1 by 2, 0, this will remain as 0. This is 9 by 2. 2 by 2 is 1 minus 9 by 2. And 0 by 2 is 0. Okay. So this whole is your y. This one is y. I hope you got that. This is x, this is y. Now, first you have to show that they are symmetric. X is symmetric and y is skew symmetric. See, final answer is just x plus y. That is, you have to show x plus y is actually coming as a. But before that, you have to show the examiner, tell the examiner that, oh, I know, and let me show you that x is actually a symmetric matrix and y is actually a skew symmetric. So I am taking y now. I am taking the rows to column. 0 minus half, minus 1 by 2 and minus 1. Then half, 0 and 9 by 2. Then 1 minus 9 by 2 and 0. Now you just take negative minus 1 common out, or you can say you multiply negative 1 inside. What do you get? 0 negative half minus 1 half, 0 9 by 2, 1 minus 9 by this minus 9 by 2 and 0. And these two are same. Y is actually equal to negative y because minus is, we have already taken minus out. So y transpose is actually equal to negative y. This is a skew symmetric matrix. And we started with this one. Now coming to x. So let us take the transpose of this. And in order to take the transpose, we have to show that it is actually equal to same metric. Transpose is same. So row column 4, 5 by 2, 0. This is 5 by 2, 5 and 5 by 2. Now last row to column 0, 5 by 2 and 1. What do you get? These two are same. The x transpose is actually equal to x. Okay. So this means this is a symmetric matrix. Symmetric matrix. Okay. So this is your x. This is your y. Now you just add them and show it to that it is actually equal to a. These are same. So x plus y, that is, I'm adding now these two. 4 and 0, then 5 by 2 and minus 1 by 2. 5 minus 1 is 4, 4 by 2. 5 by 2 minus 1 by 2 is, this is just take the difference, 4 by 2, that is going to be 2. Then you have negative 1 and 0. So negative 1 minus, I'm adding, okay, minus 1 and 0. When you add, you get minus 1. Minus 1. Now 5 by 2 and 1 by 2. 5 plus 1 is 6. 6 by 2 is 3. Right? This will come as 3. And 0 plus 5 will be 5. 9 by 2 and 5 by 2. 9 plus 5 is 14. 14 divided by 2 is 7. 1 plus 0 is 1. 5 by 2 minus 9 by 2. 5 minus 9 is minus 4. Minus 4 by 2 is minus 2. So you have a minus 2 here. So this is minus 4 by 2, minus 2. Then 0 minus 1 0, no 0, we are adding 0 plus 1 is 1. So this is your x plus 1 and that has to be A, which is coming. A, this is the value, this is the matrix from where we started. Okay, this is how we do it. Next one is define a symmetric matrix. Prove that this A plus A transpose is a symmetric matrix where A transpose is the AT is the transpose of A. So what we have to do is, symmetric matrix is simply a square matrix, which is, you can regard it as A. When we take the transpose, the same matrix should come. Okay, so I have to prove that this A plus AT is a symmetric matrix. So 2, 4, 5, 6. AT will be what? Make it as column 2, 4. This also as column 5, 6. Now, so this is AT and this is A. So I'm just adding it here only. So this will be, I'm adding 2, 5, 4, 6 with this A plus AT. So this will be 2, 2 is 4, 5 plus 4 is 9, 4 plus 5 is 9, 6 plus 6 is 12. So this is A and AT addition. Now we have to take the transpose of this. The transpose should come same. That is, I'm taking the transpose. This will come as, see, this is X transpose. So row column will be there 4, 9 and 9, 12. And the transpose is actually equal to the actual matrix. That is, if I assume A plus A transpose as X, the transpose of X is actually equal to X. This is a symmetric matrix, a square matrix where A is equal to A transpose. Express this matrix as the sum of symmetric and a skew symmetric matrix. So this question we have already done, and I showed you how whole process for with the 3 by 3 matrix. What you have to do, I'll just recall. X, you have to write it as half A plus A transpose. Y you have to take as half A minus A transpose, because when you add these two, finally A will only come. This X will come as symmetric, the Y will come as skew symmetric. I hope you'll be able to do A transpose you can do, and then just show that X plus Y, when you find out the X and Y, the transpose, X and Y transpose should be symmetric and skew symmetric. When you add these two, A should come. Express the matrix this as the sum of symmetric and skew symmetric matrix and verify your result. So this also we have already done. Okay, we have done a question like that properly. I'll just show you one more. A, then you take the A transpose. X should be A plus A transpose into 1 by 2. Then Y, this show that X transpose essentially comes to X, so that it is a symmetric matrix. Then Y will be half A minus A transpose. So when you find Y, then you take the Y transpose, it should come as negative Y. That will show that it is a skew symmetric matrix. Then finally you add X and Y, and it should come as A. Okay, this is all about this exercise. Thank you so much. Take care of yourself.